Today in this video we're gonna be looking at dimension of physical quantities. So first of all, if I could write the physical quantity, let me tell you that we have length, mass and time are the physical, and these three are the basic quantities. If I could look up the units of length, so it can be centimeter and kilometer and it can be mile, it can be meter, and it can be I guess light year. Yes, it can be light year. So there are a lot of units, right? If I could look up at mass, so we have kg, we have gram, we have slug. Slug is a unit of mass in MKS system. Okay, and if I could look up at time, so we have days, second, hours and years, right? So today we're gonna see that what is dimension, and then what we're gonna see the physical quantities and the base quantities that have dimensions. So first of all, let me tell you that what is dimension. Dimension basically means measurement of physical quantity. Okay, physical quantity, that is, in simple words, that is known as dimension. And dimension have units. So what is the purpose of this unit? If we have length, so what is the purpose of centimeter? So what does unit do? Unit describe the quantity, that how much the quantity is. For example, centimeter and meter. So we have centimeter in a more amount and meter in a less amount. Centimeter in less amount, and meter in more amount. So we have the difference, quantity difference. So these two are the units that describe the quantities. So units are basically that describe the quantity. So we can also say that dimension are the qualitative analysis. Okay, whereas while their units are quantitative. Analysis, right? Can I say this? Yes, of course I can say this. So now we're gonna see the dimension of base quantities firstly. Then we're gonna see in the next video the dimension of physical quantities. Okay, so length, we have base quantity, and the measurement of length, the dimension of length is L. Okay, then we have mass, the dimension of mass is capital M. Then we have time, the dimension of time is capital T. Then we have temperature, and the temperature dimension is Kelvin or degree. Okay, Then we have amount of substance, that is, the unit of amount of substance is mole, so it is number. We have electric current, and that electric current, the formula is I is equal to Q upon T. So ampere, like capital A, no ampere. Then we have luminous intensity, and the dimension of luminous intensity is capital J, right? So we can write these all dimension in this way as well. M, L, T. L we have 1, M we don't have any mass, length and time. So do we have any mass and length? No. That is why we have. So these powers are basically known as dimension. 0, 1, 0 is basically the dimension of length. And if I do talk about the mass, so the real dimension of mass is this, because mass is present in this and we don't have mass in length, so that is why we have 0. These powers are a real dimension, right? This is what I'm trying to say. Then we have MLT again, and we have this, and now they have T. So 0, 1, right? Then we have MLTK and 0, 0, 0, 1. Then we have MLTN 0, 0, 0, 1. Then the same goes with everyone, right? So these were the dimensions, and that is, okay. One more point I want to let you know, that the quantities, okay, the quantities, physical quantities which have same units have same dimension. Okay, I'm gonna give you the example. If I could give you the example of work, okay. So work formula is force into distance. Force unit is Newton, and distance unit is meter, Newton meter, right? So if I do talk about torque, right? The torque formula is R into F, radius. A radius unit is, it's not radius. It is radius. It is like meter and Newton, force into Newton, right? So this is also the unit of force. So this work and this torque have the same unit, Newton meter. So their dimension is what? They have same dimension. We'll prove that in the next video. Till then, bye bye.